Hi, and welcome back to our Chemistry Flipped Classroom. And in our last conversation, we were talking about kinetics, or the rates of reaction, the speed at which reactions happen. And we talked about the idea of collision theory that says that the rate of a reaction is all dependent on how many effective collisions there are. And one of the things that we talked about in terms of being able to increase reaction rate was concentration. And we said that that usually increases rate. And we finished by talking about the fact that we measure reaction rate as the change in concentration of a reactant or product per unit of time. So it's the change in concentration over time. So just like we measure our speed when we're driving a car in distance over time, so the change in distance going from one place to another over time gives us our speed. Our reaction rate measures speed by the change in concentration over time. And so our rate laws give us the rate as it is proportional to the concentration of reactants. So they express this relationship between the concentration of the reactants and the rate of the reaction. And so we represent this with an equation, we represent it mathematically, and we say that rate is equal to some constant times the concentration of reactant A raised to some power times the concentration of reactant B raised to some power. And so our goal as we go through rate laws is to figure out what X and Y are and what all of this means. And so when we talk about these orders or these exponents on these concentrations, we call these orders. An order of 1 means that the reaction is directly proportional to the concentration of that reactant. So if that reactant is doubled, then the rate of reaction will be doubled. An order of 0 means that the rate doesn't depend on the concentration of that reactant. So if I were to double it, nothing would happen to the rate. And an order of 2 means that the rate is proportional to the square of the concentration of that reactant. So let's kind of break down how this can be. So when we think about it, we said that reaction rates usually increase as concentration increases. But we also said that the whole thing is governed by the number of effective collisions, and that there's usually these intermediate steps, these activated transition states. And so if the most important collision, the collision that determines how fast the reaction can go, if that collision depends on the concentration of one of the reactants, then the rate is going to depend on the concentration of that reactant. If that reactant isn't involved in what we call a rate determining step, so if that reactant maybe comes in later after this slow step happens, then we can increase it all we want, but it's not going to change the rate of reaction. And so that's how we get that 0 order. That particular reactant, its concentration doesn't affect the speed of the reaction. And if we have an order of 2, that means that that is really important to the rate of the reaction. It usually means that 2 of those molecules have to bump into each other in order for the reaction to happen. And so we wind up with rate laws that tell us effectively which reactants are involved in the rate determining step of the reaction. So what this means, though, is that we can't just look at our balanced chemical equation and use those coefficients as the exponents, because we don't know what the rate determining step is. So we have to determine rate laws from experimental data. So a rate law tells us which reactants the rate is proportional to, which reactants it's not affected by, as well as which reactants maybe have a disproportionate effect, a squared effect. And we have to determine them from experimental data. And we'll practice determining them from experimental data in class tomorrow. So as always, I look forward to hearing your questions and continue.